In this video, we are going to be talking about the remaining chemical properties of alkanes. We had studied about oxidation in the previous one. In this one, we are talking about isomerization, aromatization, reaction with steam, and pyrolysis. So the first one, isomerization. As the name suggests, it involves the isomerization of the alkane. Basically, isomers are formed. So we're taking an N-alkane on reaction with on heating in the presence of anhydrous aluminium chloride and hydrogen chloride, it is leading to the formation of a branched isomer. So when we take an example of N-hexane is CH3, CH2 taken 4 times, 4, 5, 5, and then you have a 6th carbon atom. This is N-hexane. Now this is heated in the presence of anhydrous AlCl3, aluminium chloride, and HCl. Now this is leading to the formation of two products. One is 2-methylpentane, the second one is 3-methylpentane, and this also gives us some minor products as well. So in this reaction you're getting two products, which is 2-methyl and 3-methylpentane. So let's write the 2-methylpentane first. Second position, we have methyl group, then CH2, 1, 2, 3, 4, 5, 3, 4, 5, yeah, 2-methylpentane. And then we also get 3-methylpentane. So we're getting two products, and this has undergone isomerization. So we're getting in it has undergone the reaction where we got the isomer. So 1, 2, 3, 4, and 5. You have 5 carbon atoms. So we are getting two products. That is isomerization reaction. The next one is aromatization reaction. For you to understand all of this, for now, just remember our benzene ring. I think benzene ring this structure is synonymous with organic chemistry. So yeah, so this particular ring is considered aromatic. Why it is considered aromatic and what are the conditions for aromaticity, we'll be discussing that again in the end of this chapter. But for now, we're taking an alkane having 6 or more than 6 carbon atoms, and that undergoes a reaction at specific conditions for us to get dehydrogenated and cyclized to benzene and its homologues. So we're getting benzene and its homologues. So the first one, we're taking hexane, N-hexane, which is CH3, CH2, 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 and a CH3. Now this particular compound is undergoing a chemical reaction, and the conditions are way too many. So we are using oxides of vanadium, molybdenum, or even chromium, which is supported over alumina. So at the top we'll be writing the oxides of chromium, vanadium, as well as molybdenum. Either of these three can be used for the chemical reaction. So Cr2O3 or V2O5 or molybdenum, the oxide of molybdenum, MO2O3, and the temperature is going to be at 773 Kelvin and the pressure is 10 to 20 atmosphere. So what's going to happen is this is going to get converted to a 6-membered chain, 6-membered cycle, and basically it's going to give us benzene ring. And these double bonds can either be in that position or it can also be in this position. Why it is like this, I will tell again at the later point in this chapter. Now here, if you notice, this is aromatization or reforming. Now suppose we took an N-heptane. Okay, N-heptane is going to be just a CH2 added to here, right, and CH3. So it's a 7-membered. We won't get a 7-membered ring, but we will get a 6-membered ring with a CH3 substituted. So this is toluene. So when we are taking a 7-membered, we are getting it as a substituent on the benzene ring because we are getting benzene and its homologues. With that, we're done at aromatization. Aromatization is for an alkanes having 6 or more than 6 carbon atoms in the presence of oxides of chromium, vanadium, or molybdenum. They, at temperature 773 Kelvin and pressure 10 to 20 atmosphere, they undergo aromatization to lead to the formation of benzene and its homologues. When we take hexane and hexane, we're getting a benzene ring. When we took heptane and heptane, we're getting a toluene. The next one is reaction with steam. Over there, as it is obvious, so the methane, that is an alkane, is reacting with steam at 1273 Kelvin in the presence of nickel as a catalyst to give us carbon monoxide and dihydrogen. So let's write the reaction. Methane is going to be CH4. Steam is nothing but water. Okay, and this particular reaction takes place in the presence of a catalyst and heat. So heat and nickel, which is the catalyst. I'm sorry, I shouldn't write it like this. Okay, 1 minute. So for us to get two products, carbon monoxide and dihydrogen. So carbon monoxide, 3H2, and this particular reaction is used as an industrial preparation for dihydrogen. So this is used as an industrial method of preparing dihydrogen. The last reaction is pyrolysis. So pyrolysis basically means that a higher alkane is breaking down. It's a decomposition reaction into smaller fragments, and this is done by the application of heat, and the pyrolysis of the alkane is believed to go through the free radical mechanism. Don't worry, we are not learning about the mechanism itself, but this is the mechanism that takes place, or rather free radical process is by which we get the lower alkanes. Now the first, here we're using the example of C6H14. We are again taking hexane. Okay, now this is heated to 773 Kelvin. Okay, so the first kind of product that we could probably get is C6H12 plus H2. So C6H12, basically you're losing 2 hydrogen atoms for us to get a double bond. The next product that is possible is C4H8. And we are also getting a C2H6, which is butane. 4 2s are 8, butane, and C2H6, 2 2s are 4. So this is, C2H6, I am so sorry. So this is ethane. It can also give us C3H6 and C2H4 and CH4. So here we're getting an alkyne, I guess. No, sorry, not an alkyne, an alkene, 2 alkenes, and then methane, basically. So what is happening over here? A higher alkane is breaking or rather decomposing for us to get a lower alkane. That is pyrolysis. Now, in fact, this particular reaction is what is used for us to prepare oil, gas, or petrol gas from kerosene. So here we're using something called as dodecane. Dodecane is actually a constituent of kerosene. So its formula is C12H26. So this is undergoing a chemical reaction in the presence of platinum, palladium, or nickel as a catalyst, and at temperature 973 Kelvin, it is giving us heptane, pentane, and other products. So we are getting C7H, 7 2s are 14, heptane, right? So CnH2n plus 2, 7 2s are 14, 15, 16, plus pentene, which is basically an alkene. So alkene's general formula is CnH2n, which we'll be discussing again, don't worry. So 5 2s are 10, plus we're going to get other products as well. So pyrolysis is also useful this way. So basically we're getting petrol gas or oil gas from kerosene, and that particular thing also involves the reaction pyrolysis. So in this video we started with isomerization, where N alkanes are getting isomerized, or rather they undergo isomerization to give us branched chain alkanes and few other minor products. Aromatization reaction is basically taking in an alkane which is having 6 or more than 6 carbon atoms, and in the presence of oxides of chromium or vanadium or molybdenum, it undergoes a chemical reaction at 773 Kelvin and 10 to 20 atmosphere pressure for us to get benzene and its homologues. Based on the reaction, here we took heptane, we got toluene. If we took hexane, we just got a benzene ring. Next was reaction with steam. Methane is undergoing a reaction with steam in the presence of a high temperature, that is 1273 Kelvin, and in the presence of a catalyst to give us carbon monoxide and dihydrogen. Pyrolysis is basically decomposition of a higher alkane to give us smaller alkanes. So, and there also we get other products. So here we have an example of hexane and hexane again, and this at 773 Kelvin gave us C6H12, which is an alkene. Then it also gave us C4H8, which is an alkene and an alkane. And then these two are alkenes and this is an alkane. So basically an N-hexane breaks down to give us 3 of these products. The last one reaction over here is basically for us to extract or get the oil gas or petrol gas from kerosene. Pyrolysis is used. Here this is dodecane. This undergoes a reaction in the presence of platinum, palladium or nickel as a catalyst, and the temperature over here is 973 Kelvin for us to get heptane and pentene and various other products. So with that, we're done with the chemical properties of alkanes. In the next video, we are going to be talking about something really important and which requires a little extra effort in terms of trying to understand it well, but the moment you understand it, that basically becomes the easiest topic. So we'll be talking about the conformation of alkanes, so do check it out.